Hey guys, welcome to our channel. So before I get started on our atomic numbers, let me just say that on my not my last video, but the video before that, where I called out Brian Stavely for having a predator in helping infiltrate a predator into the Mandela Effect community, I lost a subscriber. And that's fine. If there's somebody out there that thinks that what those guys are doing is good, get out. I'd rather have no subscribers than to have subscribers who are down with predators. Now, it's kind of infuriating. I've got 422 subscribers, had 423, and I am working hard to bring real answers to the Mandela Effect community. Nobody really cares. Not nobody, but only a few people care. While this guy has 12.6 thousand subscribers, and he is working hard to bring predators into the community. And he gets 1,000 views with this evil woman sticking up for predators in a predator ring. And I question this guy. What's he doing? Bringing this woman into the community. Why are they infiltrating our community? I don't know. That's a little infuriating, but that's not, like I said, that was going to be my pretense before we get started. All right. So we've been decoding Mamwich, changing to Manwich. We got our residue, we got our extractions. Got our extractions to run through all the categories, found the University of New Mexico. We got our numerology numbers from a numerology chart, ran that through all the categories, connected the University of New Mexico to Manwich, connected that to the other 14 for a total of 15 effects through gematria. And then we converted that to the alphabetic order. Or we also got simple binary to go through all the categories, and now we're on the alphabetic order, which we've got to run through stock market, finance, genetics, medical, chemical, and now we're on atomic numbers. All right. So Mamwich to Manwich, only thing that happened was an M change to an N. And that is 1314. We used this chart to find that M is 13 and N is 14. 1314. All right. Well, start with 1. Going forward, and 1 is hydrogen. Hydrogen's in there twice, by the way. But it's a colorless, odorless gas. It has the lowest density of all gases. Some see hydrogen gas as clean fuel of the future. The clean fuel of the future, generated from water and returning to water when it is oxidized. Hydrogen-powered fuel cells are increasingly being seen as pollution-free, in quotes, or single quotes, sources of energy, and are now being used in some buses and cars. Well, I'm not surprised at that at all. They probably have been for some time. Hydrogen also has many other uses. In the chemical industry, it is used to make ammonia for agriculture fertilizer, the Haber process, and cyclohexane, and methanol, which are intermediates in the production of plastics and pharmaceuticals, because those are good. It has also been used to remove sulfur from fuels during the oil refining process. Large quantities of hydrogen are used to hydrogenate oils to form fats. For example, to make margarine, which I don't eat. In the glass industry, hydrogen is used as a protective atmosphere for making flat glass sheets. In the electronics industry, it is used as a flushing gas during the manufacture of silicon chips. Low density of hydrogen made it a natural choice for one of its first practical uses, filling balloons and airships. However, it reacts vigorously with oxygen to form water, and its future in filling airships ended when the Hindenburg airship caught fire, which is another Mandela effect. There's a Mandela effect on this. So, if you move on from that, you have atomic number 13, and that is aluminum. It is a silvery white, lightweight metal. It is soft and malleable. And I don't know how far we have to get into aluminum. It's used in a variety of products, including cans, foils, kitchen utensils, window frames, beer kegs, and airplane parts. This is because of its particular properties. It has low density, is a non-toxic, has a high thermal conductivity, has excellent corrosion resistance, and can be easily cast, machined, and formed. It is also non-magnetic and non-sparking. It is the second most malleable metal and the sixth most ductile. It is often used as an alloy because aluminum itself is not particularly strong. Alloys with copper, manganese, magnesium, and silicon are lightweight but strong. They are also important in the construction of aeroplanes and other forms of transport. Aluminum is a good electrical conductor and is often used in electrical transmission lines. It's cheaper than copper, and weight is almost twice as good a conductor. When evaporated in a vacuum, aluminum forms a highly reflective coating for both light and heat. It does not deteriorate like a silver coating would. These aluminum coatings have many uses, including telescope mirrors, decorative paper, packages, and toys. So that's 13. You've obviously got hydrogen again, but now you got 31. How about gallium? Gallium is a soft, silvery white metal similar to aluminium. Gallium at arsenide has a similar structure to silicon and is a useful silicon substitute for electronics industry. It is an important component of many semiconductors. It is also used in LEDs, light emitting diodes, because of its ability to convert electricity to light. Solar panels on the Mars exploration rover contain gallium arsenide. Well, if you believe there's an actual Mars rover on Mars, there you go. It's used there. Gallium nitride is also a semiconductor. It has particular properties that make it very versatile. It has important uses in Blu-ray technology, mobile phones, blue and green LEDs, and pressure sensors for touch switches. Gallium readily alloys with most metals. It is particularly useful in low melting alloys. It has a high boiling point, which makes it ideal for recording temperatures that would vaporize a thermometer. All right. And you move on from that, you have 3 by itself, and that's lithium. It's a soft, silvery metal. It has the lowest density of all metals. It reacts vigorously with water. The most important use of lithium is in rechargeable batteries for mobile phones, laptops, digital cameras, and electric vehicles. Lithium is also used in some non-rechargeable batteries for things like heart pacemakers, toys, and clocks. Lithium metal is made into alloys with aluminum and magnesium, improving their strength and making them lighter. A magnesium lithium alloy is used for armor plating, Aluminum, lithium, aluminium, lithium alloys are used in aircraft, bicycle frames, high-speed trains, and high-speed trains. Lithium oxide is used in special glasses and glass ceramics. Lithium chloride is one of the most hygroscopic materials known. It is used in air conditioners and industrial drying systems, as is lithium bromide. Lithium stearate is used as an all-purpose and high-temperature lubricant. Lithium carbonate is used in drugs to treat manic depression, although its action on the brain is still not fully understood, which really doesn't make any sense. Why would they use it to treat manic depression when they don't fully understand its action on the brain? Well, I think I know why. Lithium hydrate is used as a means of strong hydrogen for use as a fuel. All right, you move on from that. Let's see. You have 14. We're still going forward. And 14 is silicon. The element, when ultra pure, is a solid with a blue-gray metallic sheen. I don't know how far we have to get into silicon, but silicon is one of the most useful elements to mankind. Most is used to make alloys, including aluminium silicon and ferrosilicon iron silicon. These are used to make dynamo and transformer plates, engine blocks, cylinder heads, and machine tools, and to deoxidize steel. Silicon is also used to make silicones. These are silicon oxygen polymers with methyl groups attached. Silicon oil is a lubricant and is added to some cosmetics and hair conditioners. Silicon rubber is used as a waterproof sealant in bathrooms and around windows, pipes, and roofs. The element silicon is used extensively as a semiconductor in solid-state devices in the computer and microelectronics industries. For this, hyper-pure silicon is needed. Silicon is selectively doped with tiny amounts of boron, gallium, which we just had, and phosphorus or arsenic to control its electrical properties. Granite and most other rocks are complete silicates, and these are used for civil engineering projects. Sand, silicon dioxide or silica, and clay, aluminium silicate, are used to make concrete and cement. Sand is also the principal ingredient of glass, which has thousands of uses. Silicon and silicate is present in pottery, enamels, and high-temperature ceramics. Silicon carbides are important abrasives and are also used in lasers. All right. Now you got 4 by itself. Atomic number 4 is beryllium. Beryllium is a silver-white metal. It is relatively soft and has a low density. Beryllium is used in alloys with copper or nickel to make gyroscopes, springs, electrical contacts, spot welding electrodes, and non-sparking tools. Mixing beryllium with these metals increases their electrical and thermal conductivity. Other beryllium alloys are used as structural materials for high-speed aircraft, missiles, spacecraft, and communication satellites. Beryllium is relatively transparent to X-rays, so ultra-thin beryllium foil is finding use in X-ray lithography. Beryllium is also used in nuclear reactors as a reflector or moderator of neutrons. The oxide has a very high melting point, making it useful in nuclear work as well as having ceramic applications. That gets you through going forwards. Now, come back. All you got to do is hit 41 because we already hit 31. So 41 is niobium. Niobium is a silvery metal that is resistant to corrosion due to a layer of oxide on its surface. Niobium is used in alloys, including stainless steel. It improves the strength of the alloys, particularly at low temperatures. Alloys containing niobium are used in jet engines and rockets, beams, and girders for buildings and oil rigs, the oil and gas pipelines. This element also has superconducting properties. It is used in superconducting magnets for particles, accelerators, MRI scanners, and NMR equipment. Niobium oxide compounds are added to glass to increase their refractive index, which allows corrective glasses to be made with thinner lenses. So, and that gets you through going forwards and backwards in atomic numbers. We'll do artificial intelligence next. And so that's going to be it for this video. So for now, guys, thanks for all your thumbs up, thumbs down when appropriate. Thanks for all your comments, leads, feedback, and subscriptions. And thanks for watching, guys. And for now, you guys have a great rest of your day.